In the last lecture, you learned how to vertically translate a sine or cosine function. Now we'll learn how to horizontally translate a sine or cosine function. Let's remember, if we have a function y equals f of x, then the function y equals f of x plus c shifts the graph to the left c units. That's if c is positive. Okay? F of x minus c would shift to the right c units. For example, let's sketch the two functions y equals x plus 2 squared and y equals x minus 1 squared. Well, the first thing we have to figure out is what does the graph of y equals x squared look like? We'll graph that, and then we'll horizontally shift it. You may want to review the earlier lectures when we talked about translations. There's x squared. Okay. Now we want to graph x squared, x plus 2 squared, and x minus 1 squared. Okay, so notice this is the same thing as x plus 2 squared, or f of x plus 2. Okay, this is f of x. This is f of x plus 2. So that means we're going to shift this function to the left 2 units. Okay? On the other hand, this is the same thing as f of x minus 1 here. That means we're going to shift to the right 1 unit. Okay? Nothing to it. So the same thing is going to hold for a sine or cosine function. For example, let's sketch this function here. We usually don't say horizontal translations when we're talking about a sine or cosine function. Whenever we horizontally shift a sine or cosine function, we'll call it a phase shift. So a horizontal translation of a sine or cosine function will be called a phase shift. Okay? It means the exact same thing as horizontally shifting. All right, let's try to sketch the graph of y equals sine of x minus 2. Well, the first thing we'll do, we'll sketch y equals sine x. Okay, and notice here, this means I'm going to horizontally shift to the right, since it's negative in here, pi halves. So we're going to take the sine function, and then we're going to shift it to the right pi halves. So now shift right pi halves. Okay? So that's how we're going to do this problem. So let's start by first sketching sine x. Okay, sine of 0, remember, is 0. That's kind of your starting point. These are increments of pi halves. Sine of pi halves is 1. There's pi, etc. So there's your sine function. Remember, it has a period of 2 pi. It takes an interval of 2 pi for this thing to start repeating itself again. So there is y equals sine x. Now what we want to do is we want to shift this thing to the right pi half units. All right, so wherever I see a dot here, I'm going to shift it to the right pi halves. So this point will go there. This point will go here. This point will go here. This point shifted to the right pi halves to there, etc. So I'm taking every coordinate here, and I'm just going to move it over to the right pi halves units. And then we'll sketch. And there is y equals sine of x minus pi halves. Really nothing to it. Now, if I was to graph, say, cosine of, say, x plus pi thirds, well, what would I do? I won't do this problem. We'll just go through it. What we'd have to do, first thing, we would sketch y equals cosine x first. We know what that looks like. And then we would shift which way? Well, we'd shift to the left pi thirds units. Okay? So we want to start recognizing. Remember, if we had something like this, that's going to be a vertical shift. Something like this, where we're putting things inside the cosine function, those are going to be phase shifts or horizontal shifts. So practice on your homework. If you have questions, stop by the Pulliam Math Center, and we can help you get your homework done there.